Hey folks, welcome back to Module 1, Part 1. This is the second part of this module, and today we're going to talk a little bit about computer networking and how computers are able to talk to each other. So in the beginning, computers were standalone devices. They just did their own processing, and you got an answer directly from the computer that you asked the question to, and that worked really well. But then eventually people realized that if computers could talk to each other, it would be cool because you'd be able to transfer information back and forth between them. And over time, that has grown into what we now know as the internet. The internet's basically just a very large connection of computers that can exchange information back and forth in a useful way. So there's a couple of terms that we should know about here. The first term is going to be a LAN, L-A-N, which is also known as a local area network. A LAN is used when you have computers that are near each other that need to be able to talk to each other. And so in your house, for example, you may very well have a LAN where you have computers that are plugged into your router that you have from your ISP. And so a LAN is usually either a physical connection, so it's either going to be Ethernet cables, or it could be a wireless connection using Wi-Fi. And it is just allowing you to talk to other computers that are directly connected to that same device. A WAN or a WAN is a wide area network, and this is allowing your computer to speak with computers that are far away from you. And it's really just a matter of whether you're physically connected together in one house or whether you're connected to another house and other houses and other businesses outside. So with regard to local connections, you're probably going to use an Ethernet cable if you're going to do it with a physical cable. And the terminology there is you would be using a Cat5, Cat6, Cat7 Ethernet cable. The Cat number is just short for category, and so like a common one that you'll find is a category 5E cable, and that's capable of doing gigabit speeds, which is probably the speed that you're running at in your house. Internally, it just talks about how the wires are twisted in a specific way and the quality of the wire that has to be used. Beyond that, they're all the same. There is 8 little strands of wire that come to a connector at the end, and that plugs into a network port in the back of your computer and into your router on the other side or your switch. If you want two computers to be able to talk to each other, generally you're going to need some form of a switch, and that's an example of a switch down there. That looks like that's an 8-port switch, and they come in 4-port, 8-port, 16-port, 32-port, 64-port, 128-port. You can get big, complex switches. But generally all that happens is one computer plugs into this port, another computer plugs into that port, and then what the switch does is it allows the two computers to talk to each other. Each computer has its own Ethernet cable that runs to the switch and is capable of talking to the switch. The switches have a little onboard processor, and they keep track of what computer is on each of the ports. And so they know that this computer is, let's say, computer number 1, and this computer is computer number 2. And so it knows if there's a message for computer number 1, it sends it out that port. If there's a message for computer number 2, it sends it out that port, and so on throughout all the rest of the ports. And so an Ethernet switch, as this is used to connect multiple computers together so that they're able to talk to each other. If you're not doing this with physical cables and you're doing it over Wi-Fi, there is still a device that's acting as this switch. It's just called an access point. And instead of there being physical cables where each device is plugging in, it's just keeping track of it in memory, and it has a communications chip that allows it to speak and receive Wi-Fi signals off of each of the computers. The difference between having a physically wired connection and having a Wi-Fi connection is generally the physically wired connections are going to be faster and they're going to be more reliable, whereas a Wi-Fi connection is subject to other interference that can be coming. If you live in a house or an apartment where there are people right above you or right next to you, you can probably see their Wi-Fi network if you open up your phone and look for a list of Wi-Fi networks that are available. And when you're speaking to your access point in your house, that traffic is happening on a similar frequency, and it's actually technically slowing down your neighbors. And the more people that you put together, the harder of a problem that becomes. And they do try to solve it in ways by moving you to different frequencies, but it's still a problem. All right, so how do you know which computer you want to talk to? We, as humans, we all have names. But computers don't individually have names. I mean, they may use a name, but we'll get to that in a moment. The way that computers are addressed is with an IP address or an Internet Protocol address. So an IP address is going to look something like this. This one is 10.0.0.1. you're going to see 4 numbers with a period in between them. Each number is a number between a 0 and 255, and so you could have 10.255.1.10 or something like that. So each computer in the world has its own unique IP address for the most part. If you want to be connected to the internet, it is true that you must have a unique IP address. But inside of a local network or a LAN, you can actually use something called NAT, which allows you to hide a bunch of computers that have the same address as other computers that other people are using. And this is necessary because, quite frankly, when this originally was created, they decided 0 to 255 with 4 digits. Well, if you do the math on that, it's 255 times 255 times 255 times 255 possible IP addresses, which sounds like an awful lot. It's not. It turns out that we ran out of IP addresses many years ago. And so, as more and more people get more computers and more devices, and more things need IP addresses, we had to find a way to make that work. And so, inside of your house, you probably use one set of IP addresses that are NATed or network address translated to a single IP address that connects out to the internet. Because it turns out many devices in your house can all talk out through one IP address. And then when the signals come back, your router can send it back to whomever asked for it. And that's the idea of NATing. So when one computer wishes to speak to another computer on a LAN, what happens is the computer that's speaking creates a packet, which is just a blob of data, and it sends it out its Ethernet port with an address of its destination at the top. So it's kind of like me speaking to you. We'll assume your name is Jane, and I'm speaking to Jane. So what I would do is I would create a packet. At the top of it, I would write Jane, and then I put the message that I want in it, and I send it out on my Ethernet port. Hopefully, the switch sees that packet and it says, oh, Jane, she is located on port number 6. So it sends that information to port 6, and then hopefully Jane receives it on her Ethernet cable so that she can take a look at that data. And then if she wants to send me something back, she sends a packet back down her Ethernet cable and says, Enda, and then has the message, whatever it is. And so that's how we can communicate. The only thing that's different with computers is instead of a name, it's going to be this IP address. So if I'm computer 10001 and I wish to speak to 10002, I write 10002 in the header of my packet, and then the data has whatever communication I want to send there. And this is how it actually all really works. The information is sent locally between your computers anytime that they need to talk to each other. The switch knows which particular person is on which particular port, and as long as you're all within a LAN, the switch handles everything and just sends things back and forth. And you've probably seen this in your house. There are probably devices in your house that occasionally talk to each other. And so what's happening there is each one is sending its signal to either an access point or a switch, and then the switch is taking that signal and relaying it to the other device, and each device knows its own IP address. That's something that you set in the device. So what happens if you run out of ports? We saw that 8-port switch, but what happens if you have 10 computers or 15 computers that need to talk to each other? Well, what you do is you just buy another switch, and you connect the 2 switches to each other. So for example, we might have one 8-port switch and another 8-port switch, and then there's one cable going from one port of each to the other. That allows you to now use 14, it would have been 16, but you lost 2 for the connecting cable, 14 devices. And if you run out there, you can add a 3rd switch and a 4th switch and a 5th switch. And so when you think about a building that has a lot of computers, and if you think about the Atrium building here at KSU, there's hundreds, if not thousands of computers on all the different floors. And so obviously they don't all go to one switch. Usually what happens is each section of each floor has a switch, and all the computers connect to that switch, and then that switch connects to the next switch further down the hallway or on the next floor, up or down, in whatever way. And so these uplinks between the switches allow a computer on one floor to talk to a computer on another floor. It sends its signal and says, I want to talk to Jane, down its cable. The first switch says, well, Jane is on port 8, which happens to be an uplink to another switch. That goes up to the other switch. It says, oh, you're trying to get to Jane. As far as I know, that's on port 3. So it sends it to port 3, which might be an uplink to another switch. And that switch says, oh, I know where Jane is. She's on port 4. And it sends it out to Jane. And so that's how the communication works. And likewise, coming back the other way, it will all do the same in reverse. So each individual computer is plugged into one port on one switch somewhere. And then generally all the switches are connected together to produce a larger LAN where you have tens or hundreds of computers. So You can actually do this all the way up to thousands of computers on a local LAN, but at some point you're going to want to be able to connect to devices that are further away from you over a VLAN. So before I go there, let's talk about Wi-Fi. The access points, if you look at the ceiling in most of the rooms in the atrium building or in your house, you have a Wi-Fi access point somewhere. That access point has a network port on the back, and it likewise still plugs into a switch. That access point just acts as a relay between the Wi-Fi devices and the physical devices. And so effectively what happens is when you become in range of the Wi-Fi access point, your computer, your phone, your tablet, or whatever communicates with the access point. It shares a password to prove that it is supposed to be allowed on the network. The access point says, yep, I know who you are. It assigns it an IP address and says, you're now 10.00.15. And then forevermore, that device, as long as it's within range of the access point, can talk back and forth to the access point. When the access point receives a packet, if it's not something that it needs to send back out on Wi-Fi, it takes it, puts it on the Ethernet cable, and sends it off just like any other computer would have. And so that's how you can have a device that's physically plugged in and a device that's on Wi-Fi speaking to each other. All right. So somewhere in your house, beyond all of these switches that you may have, or access points, there is a connection to the internet. So you pay for a service to have a connection to the internet. And usually you're paying a provider. It might be Comcast if it's a cable connection. You might have AT&T if it's DSL. You might have Google Fiber or AT&T Fiber or any other provider that might be out there. So generally, some provider ran a physical cable to your house. And at the end of that cable, they plugged in a router. That router is your connection to the internet. Everything on the other side of that router in your house is a LAN, and then all of that LAN funnels to that router anytime that you need to talk to somebody on the internet. And so the way that that works is if I am 10.0.0.1 and I need to talk to somebody that's on the internet, that's, let's imagine it's google.com, then what's going to happen is I'm going to make a packet, and instead of writing Jane at the top, I'm going to write google.com at the top. Effectively, it'll be their IP address, and I'm going to send that down my signal or down my Ethernet cable. That's going to eventually reach the router, which is going to say, okay, I need to route this to Google. And just like the local connections that you have in your house where you might have multiple switches, once it leaves your house, it's going to go through a bunch more switches. So somewhere in your neighborhood or down the street, there's going to be a large metal box on the side of the street, and that box is one of your local connection points, which effectively has switches in it that go to all the houses in your neighborhood. From there, there's a bigger cable that connects back to a central point where your ISP gets the data and aggregates it and sends it on its way. And effectively, your ISP, if you were on a Comcast address and you're trying to talk to somebody else on Comcast, then effectively what happens is your connection comes in, and then it realizes that it's another one of their customers, and it just sends it out on a different port on a switch locally within Xfinity or Comcast or whatever they're called. And then if you need to go to somebody on a different ISP, they likewise have an uplink connection that goes to other ISPs. And so the internet is just this big, complicated set of switches, effectively, where information is sent from one computer to another via a bunch of intermediate switches. Your ISP just provides you with a connection outside of your house. And the speed of that connection is something that you pay for from your ISP, and they may have limits on how much data they will route from you and stuff like that. So you can think of an ISP, which is an internet service provider, as effectively a giant LAN. In reality, it's a WAN because you're connecting across a wider area network. But really all it is a bunch of switches that are connecting buildings together and cities together and so on and so forth. And then your ISP and every other ISP in the world connect together as well so that you can get from any computer to any other computer if you know who it is you want to talk to. So let's take an example of downloading something from, let's say, Wikipedia. So if I open up a browser and I type in wikipedia.com and I hit enter, how does that actually work? Well, the first thing that happens is my local internet browser, whether it's Chrome or Safari or Firefox or whatever else, my internet browser will have to look up the IP address for wikipedia.com. And that's done through a service called DNS, or Domain Name System. DNS takes a name that is familiar to us and converts it into an address, similarly to how you would look up somebody's address in your phone contacts app. And so the computer converts the name that I typed in, wikipedia.com, into an IP address. And then my computer makes a packet with the IP address of Wikipedia on there. It sends it out my Ethernet port or up through Wi-Fi up to an access point, and it says, I would like to get the front page of Wikipedia. That request gets routed to my router and then off to my ISP, and then from my ISP to whomever other's ISP it is that services Wikipedia. And eventually it gets to a server somewhere in a data center that looks like the servers that we looked at, which is one of the Wikipedia servers. That server gets the request and says, oh, you want the front page? It makes a packet with the front page in it, and it sends it back all the way across the internet until it reaches my computer. My computer then gets it. It's going to be in a format called HTML, which we're going to look at a little bit later on, and my computer converts that into a web page that I can see. And then when I click a link, the exact same thing happens again. A request is sent off to the Wikipedia server that says he now wants this page. The Wikipedia server responds with, here is the page that you want. And then that can keep happening as much as you want. This is how everything works. When you turn on a movie, let's say on Netflix, what's going to happen there is your app on your phone or on your TV or wherever it is going to make a request to a Netflix server that's in a Netflix data center somewhere through your router and access point and all the way across the internet until it gets there. And you're going to say, I want to watch the latest episode of Stranger Things or whatever it is you're going to watch. And then they're going to start taking blocks of video, which they encode as computer packets, and they send those packets back to you across the internet. And as your computer receives them, it draws them on your screen for you, and it makes sure that it has enough of them in its buffer so that if your computer is interrupted for whatever reason or your internet is interrupted, you can still see the remainder of the show, or at least see a good chunk of the show before it would cut off. So that's how video streaming works. It's how web pages work. It's how everything on the internet works. Every game you play, when you open the app, it connects to the central server and tells them that you're now playing that game. And then any actions that you do in the game, if it's a multi-person game, those are relayed back to the server, and the other person who's playing it, they're getting their version of it as well. So any computer that you speak to on the internet, whether it's a web page or a gaming server or a streaming media service or anything else, a social media server, they all have their own servers in a data center that they're paying for. Those servers look exactly like what you saw in the beginning of the last presentation. They may have thousands of them because they may have to handle thousands of requests simultaneously. When you ask for something, you're just getting directed to one of those computers who answers you. You get your answer back, and then if you're done, that's great. If you're not done, you go back and you ask for the next thing that you want, whether it be the next block of video, the next part of the song, the next web page that you want to see, or whatever it is. All right, so how do these large connections work? So we've talked about Cat5 cables being an Ethernet cable, and the problem with Cat5 cables is, or Cat5e or Cat6 or Cat7, is they're limited in how fast they can go. They can generally go up to about a few gig per second, but you generally can't do 10 gigabits or higher on a Cat5, 6, or 7 cable. So if you need to go faster than that, then how do you do that? And the example of that is, it's great that your connection to the internet may be a 1 gig connection. Maybe if you're in an area that has fiber, you might have 1 gig out. That's probably about as fast as you might have now. You could have 2 gig. There's a few people that offer that. So that means that the fastest you can send information out of your house is 1 gig. But you're not the only house in your neighborhood served by that ISP. So if there are 10 houses in the neighborhood needing to send 1 gig at the same time, they need 10 gig out of your neighborhood. If there's 100, they need 100 gig out of your neighborhood. Now, they don't really build all the capacity so that everybody could do 1 gig at any given moment in time. Really, they build the network such that they're assuming that at any moment only 1 or 2 people are doing it. So they maybe build 10 gig out of your neighborhood if they're giving everybody a 1 gig signal, and they just kind of cross their fingers that not everybody is going to hit at the same moment. But how do you get 10 gig out of a neighborhood if a Cat5 cable or Cat6 cable or Cat7 cable can really only go up to 1 gig in speed? Well, the answer is you need a faster cable type. And so faster than copper cables like Cat5, 6, and 7 are going to be fiber optic cables. A fiber optic cable is a glass tube that a light can bounce around in. And the cool part about it is that as the light hits the top of the tube, it's exactly reflected down and no light is lost. So it bounces all the way up and down the tube at a very reliable speed, the speed of light, as it turns out. And the cool part about a fiber optic cable is you can transmit data very long distances without losing anything. The problem with electricity is as you go through the wire, there's a certain amount of resistance that is pulling a certain amount of the power out of the wire. And while that's technically true with fiber, you can go much further with fiber than you can with copper. So most ISPs coming out of your neighborhood are going to have a fiber wire or perhaps a coax wire if they're a cable company. And that cable can carry just a lot more data than your individual Cat5, Cat6, Cat7 cable. The other thing that's nice about fiber cable is that you can bounce multiple different light sources at different phases and at different rotations inside of there, which allow you to have many different signals running over a single cable, which is pretty cool. All right, so I mentioned a little earlier that when you type wikipedia.com into a browser, it gets converted from the words wikipedia.com into an IP address. And I mentioned at the time that that is called the domain name system. And so that's what's written up here. DNS is the domain name system, which is responsible for converting names into IP addresses and vice versa. You can also take an IP and ask for its name. So that's the first protocol to be aware of in the internet. Another protocol to be aware of is called HTTP, or more modernly, HTTPS. This is the protocol that you use to retrieve web pages. So every time that you've typed in wikipedia.com into your browser, you're making an HTTP or HTTPS request. The difference between the two is whether or not this S is here. This S stands for secure. If you make an HTTP request, anyone who can look at that wire that you're physically connected on, or anyone who can hear the Wi-Fi signal that's going in and out of your computer, is actually able to see the request that you're making and the response that comes back. It's all broadcast in plain text. Whereas an HTTPS connection, before it makes the request, it actually encrypts the data and then sends an encrypted stream such that if anybody can intercept it, they can't read it without knowing the key. So HTTPS is what everybody is moving towards, and almost all connections on the internet these days are HTTPS rather than HTTP. Both of these protocols can be used to retrieve web pages, videos, images, sound, or streaming information off the internet. So how do you tell the server what it is that you're interested in? Well, that's done with a universal resource locator, or a URL. A URL is what you're typing into your browser. When you type wikipedia.com, that's a URL. And you know from this class that you will sometimes go to ccse.kennesaw.edu. That gets converted by DNS into an IP. But then you might have at the end of it /fye/courseschedule.php. When you put that extra two things on the end there, that's part of the URL. So a URL is not just the name of the server that you want to talk to, but it's also the particular folder or directory that you're trying to retrieve from that server. When you put all that together, it's called a URL. So ccse.kennesaw.edu/fye is an example of a URL. There are many other protocols on the internet that are used to do different things. SMTP, POP, and IMAP are all used for email. So anytime you've sent an email or received an email, it was transmitted with SMTP, and you might very well have retrieved it via POP or IMAP. You may have used a remote desktop connection at some point if you've ever done like a Chrome remote desktop or a Meet Me, or even when you're in a Teams meeting, you might be able to show your desktop to somebody. Those are all done through remote desktop software. And again, just different protocol that runs on the internet. Database servers tend to be on a different protocol on the internet as well, and they allow you to get information and send information. So there are lots of different protocols, but by far the most common one, and the one to be aware of, is HTTP, HTTPS. That's the most common protocol on the internet, and DNS is a very common one that's used as well in the background. So this last slide, we're going to open up a command prompt and we're going to type in ping www.google.com. So what this is going to allow us to do is it's going to allow us to see whether a particular server on the internet is alive and whether it's responding. So I'm going to open up a command prompt. Depending on the particular operating system you're on, this is a different thing. If you're on a Windows machine, you would type CMD to get a command prompt. In Macs and in Linux, it's generally going to be called a terminal. But either way, I have a command prompt and I'm going to type ping www.google.com and I'm going to hit enter. And so the first thing to notice here is that it's giving me back a whole bunch of information. Up at the very top of the screen, I have ping www.google.com, and then in parentheses it says 64.233.185.105. That is the IP address of Google. And as I said, every server that you talk to on the internet is going to have its own IP address. Now, Google actually has many IP addresses. If I do this again, I might actually get a slightly different address, and indeed I did. Instead of getting 185.105, I got 185.103 the second time. And that's just because Google has servers all over the world. They're a very large organization. So the first thing that happened when I typed ping www.google.com was DNS converted www.google.com into 64.233.185.105. The second thing that happened is that the ping is a protocol that allows me to access whether a server is responsive on the internet, and it tells me about that server. So what it did was it created a packet from my computer and it sent it with the address 64.233.185.105 and sent it out across the internet. I'm on Wi-Fi here, so it connected up to a Wi-Fi router, out my router at my connection to the internet, and then it went all the way from me to a Google server. And then the Google server, when it received that request, it responded to it with a ping response. And when that came all the way back to me, I was able to tell how long it took. So that first line where it says 64 bytes from yb-in-f105.le100.net, it then says ICMP sequence 1, TTL 105, time equals 10.7 milliseconds. So to be clear, what that time equals part tells me is that from the moment that this computer that I'm sitting at sent a packet to Google to the moment that it got the answer back, it was 10.7 milliseconds. That's incredibly impressive because Google is not in my house most of the time, but they're off in a remote data center. And so this connection came from me all the way out to a Google data center. This is actually particularly fast. If I were to ping somebody else, in most cases, it'll be a little bit slower. Let's see what Microsoft is. Okay, well, Microsoft is 10 or 11 milliseconds. Usually you'll get things that are more in the 30 to 40 milliseconds when you're going across the internet. So ping is a neat tool. It'll show you an IP address. It does the DNS lookup for you so that you can see that. And then it tells you if the server is alive. If you're ever trying to debug something in your house and you're trying to see if a device is on your network correctly, if you know the IP address of the device, you can go to any other device on the network and ping that IP address. And if the device is alive, it will respond back to you. The word ping comes from submarines. You can go watch The Hunt for Red October if you want to see all about ping. But anyway, so ping is an internet protocol that sends a packet and gets back a response for you. You'll see how long it takes, and I will mention to you that not all servers will respond to ping. So for example, I don't think the Kennesaw servers will. Let's see. Ping kennesaw.edu. And yeah, there you go. The Kennesaw server is not configured to respond to ping. It just depends on whether they want to do it or not. Inside your local network, everything will respond to ping. But once you go out onto the internet, it's a bit hit and miss as to whether they do or not. You can see when I stopped it, it said 100% packet loss, meaning 100% of the packets I sent never came back. Whereas when I was looking at this for Microsoft, it was 0% packet loss because 100% of them came back. So that's the ping command, which allows you to see some stuff about how information can go back and forth. So that's a very, very high level description of how the internet works. And that's as much detail as you're going to need for this class. There are certainly classes you can take to learn a lot more about that. We are going to later look at how the web page part works. That's going to be in a future presentation. So I will see you guys in the next lecture.